Good morning, everybody. Mr. Hudson here. Hey, just want to give you some notes here over the next section of the chapter, which is section 5.6, dealing with inverse trigonometric functions. Excuse me, I'm going to get through probably about a third of the notes of the entire section here, and then you will be given an assignment based on the notes that I'm giving to you. So try to keep up as far as that is concerned. Also, you've already jotted down or filled in actually the unit circles from another time that you actually were given those in class. We started with those quadrantal angles, as in the coordinates 1, 0, 0, 1, all those other points on the axes themselves. Now what you should have done by now is to fill in the other coordinates. Okay, there were like 12 other coordinates, 16 altogether. So right now I would keep that unit circle close at hand because I'm going to be following through with that and referring to that quite a bit throughout this section. Okay, so let's get started here. This section talks about inverse trig functions, as in the inverse sine, the inverse cosine, and so on. Now what I'd like for you to do is write everything down that you see here. Write down especially where it says y equals, and how that reads is the inverse sine of x. What it means is that the sine of y equals x. Now, in this case, we've talked before about the fact that the sine of an angle is always between -1 and 1. What we're going to expand on here, and I'll get a little bit more into detail with this in class tomorrow when I'm here, but at least write down the fact that the y value is between -pi/2 and pi/2. And again, that's pretty important information there. It's going to sound confusing right now, but I will explain that a little bit more in detail when I'm here so I can point some things out to you. But for now, just jot that down. And also, if anybody's needing more time, I'm actually going to go on here, so you may need to pause this. But again, how this reads is y equals the inverse sine of x, which means, and another way to write this equation, the inverse equation, is to write the sine of y equals x. So it's kind of like you can take that sine right there over to the other side, and the opposite of taking the other side, the opposite of the inverse sine, is the regular sine. So we move that sine over. Here's what it means. Here we're looking for the inverse sine of 1/2. Now what we had before was y equals the inverse sine of x, and how that can be rewritten is that the sine of y equals x. So what we're looking for is actually an angle. If we're saying that we have the inverse sine of 1/2, we're actually trying to find what angle. So another way I could write this is the sine of y equals 1/2. Now let's think for a second here. Recall that when we talked about the unit circle, that the sine value, the sine of any angle, we'll call it theta, is equal to the ratio of y over r. But with the unit circle, since the r value is always 1, we could just say that the sine is the y coordinate. And if you recall, one of the things we did, we said we find the sine of pi/2 was the y coordinate at pi/2. And if you look on your unit circle at pi/2, that y value there is 1. Therefore, the sine of pi/2 is 1. Well, let's look at what we've got here. We're trying to find out what angle has a sine of 1/2. So we're looking for where the y value is 1/2. You just wrote down a coordinate that has this coordinate, radical 3/2, 1/2. What you're trying to figure out is, what is the angle that has that y value of 1/2? And as you'll notice, the angle that matches up with that is pi/6. Therefore, the inverse sine of 1/2 is pi/6. And the reason for that is because the sine of pi/6 is 1/2. Now let's look at another example here. if we're looking for the inverse sine of negative radical 3 over 2, we are trying to find out what angle has a y value of negative radical 3 over 2. And if you look here, we've got a coordinate right down here, which is 1/2 negative radical 3 over 2. Remember, we're looking for the y value to be negative radical 3 over 2. The angle that that pertains to is 5 pi over 3. And again, look at the unit circle. The coordinate that has, the angle that has this coordinate is 5 pi over 3. Therefore, the inverse sine of negative radical 3 over 2 is 5 pi over 3. If we're looking for the inverse sine of 5, well, this is kind of strange here because you cannot have an angle that has a sine greater than 1. So this cannot happen. There is no angle. What we're trying to find is the sine of what angle is equal to 5. Well, there is no angle with the sine of 5. The sine is never bigger than 1. So this is actually no solution, or undefined, or whatever you want to call that. So that's the inverse sine, and you'll find that the rest of these trig functions are very similar to that. Jot this down here. If we have y equals the inverse cosine of x, then what that means is the cosine of y equals x. It's the same thing, same idea is the inverse sine. If we're trying to find an inverse cosine, then we are actually finding an angle which has that particular value as a cosine. Now, these x values are always between -1 and 1 again. And with the cosine, the y value, these angles are actually always going to be between 0 and pi. There is a reason for that. Again, I'll get into that tomorrow. But for now, it is important that you have all this information written down. Pause this if you need to. So as I'm finding in this first example, y equals the inverse cosine of 1/2, then what I'm trying to find out is, remember the cosine, if we have the cosine of theta, now on the unit circle, that is equal to the x value. We initially said it was x over r, but r is 1. So the cosine of an angle is the x value. Therefore, as we're finding the inverse cosine of 1/2, we're trying to find out what angle would have, I'm sorry, I didn't mean to do that. What angle, so we'll say the cosine of y, is equal to 1/2. So if we think about that unit circle, we have a coordinate right here, which is the coordinate 1/2 radical 3 over 2. The x value is 1/2, and the angle where that happens is pi over 3. Therefore, our answer is pi over 3. You getting this? Oh, you will. Be patient. So, as we're looking here, we have the inverse cosine of 0. We're trying to find out where is the x value 0. Well, that's one that we've talked about before. We have this coordinate 0, 1 right here, which is pi over 2. Therefore, the inverse cosine of 0 is pi over 2. For this last example, we'll find the inverse cosine of negative radical 2 over 2. So what we're trying to find out is where is the x value negative radical 2 over 2. Look at your unit circle. You have a coordinate over here, which is the coordinate negative radical 2 over 2, radical 2 over 2. Well, the x value here is negative radical 2 over 2. That's exactly what we're looking for. So we need to decide what angle is that. Well, that's the angle 3 pi over 4. Therefore, the answer is 3 pi over 4. And I think I stated this already, but let me say this again. When we're finding inverse sines and inverse cosines and inverse all these trig functions, we are finding angles. We're finding the angles that have those particular values that are given to us. That's no different